Hi guys, welcome back to the channel. In this video we are going to discuss the concept of decoder. So this is also a part of combinational circuits. So let's get started. So let us first understand what is the meaning of decoder. If a set of inputs passed into a circuit, after that we are going a logic circuit, basically that inside we don't know what is there. We will be going to explore what is there inside the box of decoder. The logic we are going to have with the help of circuit diagram, also with the help of truth table. So if you pass n inputs, we are going to have outputs of 2 power n. So that is known as decoder. For example, if you take a decoder, that is 2 cross 4 decoder, means 2 cross 4 means the input are 2 and the outputs are 4. That is known as 2 cross 4 decoder. If you observe, we are sending A, B, and we are getting outputs as D0, D1, D2, D3 as 4 outputs. You can say observe there. This is the truth table of a decoder. So basically in the truth table we are going to have the inputs and outputs. So inputs are A, B, 2 variables, and the outputs are D0, D1, D2, D3. So in this case we are having 4 outputs. So we are going to have 4 outputs from D0 to D3. So A, B are normal general like truth table from 0 to 3, that is 0, 0, 0, 1, 1, 0 and 1, 1. So how we are going to select the output? So if the A and B are 0, 0, then the output or the select line would be D0. Basically these 4 lines, out of these 4 lines, one line will be selected, that is our output line. So if the selection lines or the input we are sending is a 1, 1, then the output would be gone into the D3, that is the final one. Likewise, if you also select the inputs as 1, 0, the output would be going to D2. I am saying about this only. So for this example, this is a small example, I am representing each and every possible operation, so that you can able to understand clearer. So if you see, observe in the first one, that is I am sending 0, 0. So then D0 line is selected as output send in that. So if you observe 0, 1 sending, then D1 line is selected, 1, 0 D2 line is selected, and 1, 1 then D3 line is selected. That is the last line. Then we also require the output expressions for the D0, D1, D2, D3. So here there go. So if you see that according to the SOP formats, the 1 where there is 1, there we need to place the SOP or the min terms. So in the first one, that is A bar, B bar. The second one is A bar, B. The third one D2, that is A, B bar. The fourth one, that is 1, 1. In that is selected line is D3. The output would be AB. Already we have the output expressions, that is D0, D1, D2, D3. So according to that, I have took A and B, as we have already had 2 variables. So in the output expressions we have A bar, B bar also, so that I have took a NOT gate after the variable line, so it represents the A bar. So if you observe the D0, that is A bar, B bar, so draw 2 lines, that is from A bar and B bar, do AND operation, that is AND gate. So you are going to get the A bar, B bar. Similarly you are going to do all the 4 output expressions with the help of 4 AND gates. I hope you understood this. So in this decoders we have another concept called enable. So it's also included, it is very important. If suppose 4 cross 16 can be implemented with the help of 3 cross 8 decoders. So for that conversion we need to have compulsory the enable input. So for the simplicity I am representing this. So in the next video we are going to see how we can represent, how we can implement higher decoders with the help of smaller decoders. But just remember, if enable is 0, the decoder will not work. If enable 1 only, then only all decoder outputs will become as correct. So if you observe the truth table also, I have took another variable, that is E. So when enable is anything, variables A and B anything, but enable is 0, all the outputs would be 0. If enable is 1 only, then all the remaining things will be same. If you observe 0, 0 for D0, 0, 1 for D1, 1, 0 for D2, 1, 1 for D3, remaining all are same. But enable is added, that's it. So if you also want to represent the enable line, so this the way you can represent the enable line also. So AB will be, all circuit will be same, just add enable line and connect all the AND gates with the enable, that's it. Because all this decoder will work when only the decoder must and should enable should be 1. So that is the reason that all the AND gates are connected with the enable. So the next decoder is 3 cross 8 decoder. So if you observe in 3 cross 8, the 3 represents 3 inputs, 8 represents 8 outputs. So inputs are ABC, outputs are from D0 to D8, 2 cube, that is 8 outputs generally we had here. So in the similar fashion, we are going to fill the truth table as well. So if you observe, that is a 0 0 0 for the first A, B, C. If you take all the three variables as 0, so then you are going to select the D0. Remaining all things, all outputs would be 0. And the down of D0 you are going to represent with 1. The next thing, if you want to do represent that 0 0 1, or if you want to pass the variables A, B, C as 0 0 1, then the output would be, or selected line would be D1. The output 1 is D1. So remaining all are zeros except the under D1. In the similar fashion, the number or the binary digit, that is, suppose if you take 111, that is a binary number. So if you convert to normal decimal, that is 7. So the decimal under 7, that is D7. So under that you have to represent 1. So likewise, if you take 110, that is 6. So D61. So if you take 511101, that is D5. So similarly, you have to fill all the truth table like this. You will get diagonally 1 elements. So this is the truth table of 3 x 8 decoder. So next thing, we are going to draw the circuit diagram as well. So if you observe here, we are going to take SOP format. So wherever there is 1 in the D0 column, you are going to take that in the SOP format, that is A bar, B bar, C bar. If you observe the last one, that is 111, so in the D7 position, or the equation of D7 can be have in the 1 position, that is A, B, C. So similarly, D1 column, D2, D3, like that you have to obtain all the expressions. So instantly we are going to draw the circuit diagram. So if you observe, we have 3 variables because this is 3 x 8 decoder. So 3 variables are A, B, C. So in the output expressions, we also had the B bar, C bars also. So we are also obtain the B bar, A bar, C bar also. So after obtaining as same in the previous situation, we are also going to have the 8 AND gates to produce 8 product terms. So if you observe A bar, B bar, C bar, the D0. So you are going to connect with the A bar, B bar, C bar. Similarly, you are going to connect all these things. Suppose D7, that is ABC, you are going to connect with ABC, like similarly. So in this 3 x 8 also we have enable concept. So in every decoder, enable will be there. So we have to represent the enable. So after representing, I change the truth table also. If you observe the truth table, whatever may be the ABC, if enable is 0, all will be 0. If enable is 1, then all circuit or truth table will be same as it is. Already we have done this. The diagonally ones will be present, remaining all things will be 0. If you want to draw the circuit diagram of 3 x 8 decoder with enable also, so all the circuit diagram will be same, but you have to draw extra enable line and you have to connect with the AND gates. And if you also observe, so enable means if you connecting to AND gate, the output should be D0 is equals to A bar, B bar, C bar dot E. So then why you are not writing out in the output E? So this question might be coming in your mind, but I will say one thing: enable means always 1. So if you want to represent or not, that is our wish, because if you represent, that is again 1, so no need to represent that, because A bar, B bar, C bar into 1, that is again the same thing. So we are not going to represent, but we are going to connect to represent this is the circuit diagram to the AND gate. And finally, we are going to see 4 x 16 decoder. So if you observe there, directly I am writing there, you can see. So there are 4 in terms, that is input terms A, B, C, D, and total there are 16 output terms starting from D0 to D15. So I already connected the enable line. So let's see the truth table and circuit diagram for it also. So this is the truth table for 4 x 16 decoder. So truth table is quite large, right? So all are zeros except the diagonal elements. If you observe, I also directly included the enable also. Enable is 0, nothing, all will be 0. So if enable is 1, then all the outputs will be present according to the input equation. That is, if you observe ABCD as 0, 0, 0, 0, 0, so that will be going to select D0. If all are ones, 1, 1, 1, 1, 4 ones, then it will be going to select D16, that is D15, we can say. Means last term, whatever the last term, that line will be selected, that is D15 in this case. Likewise, if you means according to the decimal, we can say simply the binary equivalent to decimal. Suppose if you observe the 10, that is 1010, that will going to select D10. I hope you can fill this all table. So even though if you're not representing the zeros, it's not a problem, but you have to represent all the ones, or you can simply represent 0 0 corresponding to D0 and 1 1 1 corresponding to D15, like that you can simply represent also without representing this table. So the circuit diagram is also drawn in the same fashion. So there we have four variables, that is A, B, C, D, because we had 4x16 decoder. So according to that, we are going to have 16 output terms, means 16 AND gates. So each AND, so enable also I am representing directly, each AND gate will be directly connected with the enable line. So AND gate, and according to the output expressions, that is first one, if you observe, that is A bar, B bar, C bar, D bar. So we are also going to connect with the corresponding the variables, that is first one A bar, we are going to connect B bar, C bar, and D bar, finally E. Similarly, that is D1 and up to D15, according to SOP formats, we are going to connect all the variable lines. So I hope you can fill out all the between things. So it's a simple thing, I can say. So this is the circuit diagram for 4x16 decoder. So I hope you understood the basic thing of 2x4 decoder, 3x8 decoder, and 4x16 decoder. So these are the three basic decoders. We have another decoders, many things up. There are higher decoders also, that is 5x32, and many more things. Like we also know that is if you pass n, we are going to get 2 power n. So there are many things, but these three are the main things that we are going to use if any application needed. Or in the general sense, these are very simple. So that's why we are using this. Thanks for watching up to now.